All right. Welcome back to episode 7, lecture 7 of Econ 300. In this lecture, we're going to finish up the supply side of things. We're going to work with theory of the firm part 2, and in the next two lectures, we'll actually get to equilibrium. We'll actually see supply and demand together. But first, before we begin, I just wanted to give a few announcements about a few of the things that we're going to expect next in this class, and some things that you guys probably care a little bit more about than usual. So this is going to be lecture specific material. All right. So the first thing that I want to speak about before we get to the real lecture um, is the test. All right. The midterm, that is. All right. So the midterm is not going to be this Wednesday. It's going to be next week on Wednesday. All right. And let's go ahead and just write this out. That the midterm is next week on Wednesday. Next Wednesday, and I have that as 7:23. All right. So do not miss it. This will be at the time that is listed on like your my UW for this course. So I have that as I have it at 3:30 p.m. to 5:40 p.m. And then this is Pacific time. I think it's PDT because we're in daylight savings. But I'll nonetheless, so this is when we're gonna have the midterm. All right. This is when we're gonna have the midterm. I think this is actually even 20 minutes longer than I had thought. I thought this class ended at 5:20. So this one actually ends at 5:40. So you'll have 2 hours, 20 minutes for your midterm. All right. So do not miss this. All right. I'll send an announcement about this part, but if you have any DRS accommodations, I didn't get, as far as I'm aware, I didn't get any notifications that anybody had DRS accommodations. So if you have those, like if you went through the DRS office and you're supposed to get some like you need some special accommodations for tests, then you need to let me know immediately. All right. You need to let me know immediately so that I can sort these things out so that we can get a plan going. All right. Otherwise, it's going to be at this time for everybody. And as it is currently, I have no alternate times for the exam. Nobody has reached out to me, and I don't have any DRS accommodations notifications in my email. So as it stands right now, at least at the time of recording this video, this is it for the midterm. All right. There's no alternate. If you miss it, you're kind of out of luck. So please make sure you can make this. And again, I specify that this is Pacific time because I know some of us are traveling, maybe internships this summer, or maybe we're visiting family, or just for one reason or another, you're not in Seattle right now. Um, just make sure you're online at this time next Wednesday. All right. Then this is the Zoom exclusive information that I want you guys to watch this video for. All right. Is that what am I going to ask on the midterm? All right. What am I going to ask? Well, if you look, one of the things you might notice essentially is if we go here to the Canvas page and we see that essentially, if you ignore the introduction part, I have behavior consumers 1 and behavior consumers 2. Have consumer theory 1 and then consumer theory 2. And then I have theory of the firm 1, and then today will be theory of the firm 2. What I'm getting at is that basically for the contents of the midterm, you could basically break it down into we've talked about what have we talked about? We've talked about a demand 1. We've talked about essentially, I'm going to break it into 4 groups, all right? We've talked about like you can call it demand 1 and demand 2. And then we talked about on Wednesday last week. I'm sorry. Yeah. What we talked about on Wednesday last week and Monday today is supply, all right, theory of the firm. And then the last thing that we're going to cover is equilibrium. And this is only equilibrium in perfectly competitive markets. So perfect competition. All right. So this is essentially what 1 through 3 is what we will have covered by the time you see this video. And then part 4, chapter 4, if you will, if you care to. That's what we'll talk about on Wednesday this week and Monday next week. All right. These 4 chapters, these 4 contents are what I'm going to test on. All right. What I think I'm going to do is I think I'm going to make it be 4 parts, and I'm going to have a set of questions from each part. All right. So I'm going to have a set of questions for demand 1, a set of questions for demand 2, one for supply, and then one for the equilibrium, for the perfect competition, perfectly competitive equilibrium. All right. That's how I'm going to design the exam. And that's how I suggest that you study for this exam. All right. You should understand well which topics map to which chapters. All right. So yeah, I'm gonna have 4 parts, one from each of these sections. Um, and this is how we're gonna do it. Or that's how we're gonna do it, all right? One, like a chunk of questions for each of those sections. All right. And then I had thought long and hard about this, and one of the things that I realized, mm, and I kind of was aware of this coming into this, was that given that this is an 8 or 9 week summer session, and I'm giving you guys a ton of information. Like I'm very aware that I'm giving you guys a ton of information. So as a result, the exam will be open note. All right. The exam will be open note. So now when I say this, this means that you can use your notes. And this is where I really like those of us that have like taken notes on like pen and paper, or even if you're using like good notes like I am, like handwritten things. I like that a lot because then I can just see you swiping through or opening your notebook, and I know that you're just looking at your notes. What I don't want to see is I don't want to see any typing. All right. I don't want to see anybody copy and pasting these questions or typing them into ChatGPT or Grok or Gemini or any of the other LLMs. All right. That is an immediate red flag. And if I notice that, then we're gonna have some problems. All right. So I'm being generous with you guys. I know it's a lot of information, so please use your notes. All right, I'm not teaching you this for no reason. Use your notes. You're welcome to use it. I want you to use them to solve these problems. Um, but I want you to solve these problems. All right, I don't want the LLM to solve these problems because unless they're basic, the LLM is probably going to get something wrong. All right, and I'm designing these questions. All right, I might take some influence from the textbook, but I'm designing these questions, and so I will write them in a way such that the answers that you should come to, you will be able to come up with them. The LLM may not be able to. All right. So just a warning, just a warning. All of that to say, the exam next week will be an open note exam. All right. Now, for those of you that are familiar, um, this means they're not going to be super easy questions, but you're going to have your notes accessible to you. All right. So I still encourage you to review your notes. Um, but you will have them with you during the exam. But you should probably have looked at them before exam day. All right, that's just a word of advice from me to you. Word to the wise. All right. What else do I want to say? What else do I want to say? It'll be open note. The way it'll go down is that like I will post the exam document at 3:30 sharp. That way you guys will be able to open the exam document while we're all on Zoom together. You're going to log on to the Zoom. Once I confirm everybody's on Zoom, then I will publish the document in the Canvas, on the Canvas page. And then you will have the full 2 hours, 20 minutes to work on it. and then I'll probably give an extra 10 minutes for you to like upload your files at the end of the exam, at the end of the exam period. All right. And that's how it's gonna go down. So exam must be handwritten. Must handwrite your answers. All right, you must handwrite your answers and you show your work. If you don't show your work, then I cannot give you credit. I need to see how you solve the problem. All right. So you must handwrite your answers and you must show your work. Some of you guys take notes by typing, and that's cool. I don't really care how you take notes, but for exams, you must handwrite the answers. All right. So that's what I wanted to say about the exam. Um, that's all I have written for what I want to say. Um, Yeah, as far as test news. Any other questions you guys have, please reach out to me. But this is what I wanted to make a note of before I actually get to the actual lecture. All right. So we know when it is, and you guys should book that space off in your calendar right now. Next Wednesday, you're busy at this time. All right. And then this is what's going to be covered on the exam. You're going to get a question or a chunk of questions from each part. All right. You're going to get one, two, three, and four. And like I said, you can expect a question from each part. It'll be an open note exam. That said, you must handwrite your answers and show your work for every answer. But so long as you can do that, you should be in good shape. And I'll try to make the exam questions like they should be pretty similar to the homework questions that I've been given. Because I kind of take a blend of like homework questions I'll take from the textbook. From the exam, I'm gonna style them up in my style, what I want you guys to learn or be able to like reproduce in a time constrained environment. All right. So I'm not gonna give anything that's like unaccessible in the 2 hour period. All right. I'm not gonna ask you for nothing crazy. All right. I'm gonna keep it reasonable, especially you're gonna have your notes with you. So it'll be very reasonable, it will be very doable, but it should test your knowledge. All right. And that's all I have to say about the exam. That's all I have to say about the exam. When you see this posted document, it won't have this information on there. I'm gonna send an announcement after this with some of the important stuff, like the time, but all of this stuff right here, this is what you get for tuning into the lecture. All right. So yeah, yeah. And remember, one last thing, not even one last thing, sorry. Um, with that said, with everything said, one of the things that I alluded to, one of the things that I alluded to was that I know that it's a lot of content. All right. I know that it's a lot of content. So let me just remind you guys that my job here with teaching Econ 300, um, they gave me this course to teach, and this is a very important course. All right. This is a very important course because it gives you all of micro theory. Um, and we're doing it in a summer session. So the quarter system is already fast as it is. The summer session is going to be even faster. All right. It's even more compressed. It's a shorter amount of time. So I know I'm hitting you guys with a lot of knowledge right now. I'm very much aware. Um, this is partly for your own good, even if you don't commit to memory and you can't recite every single thing that we talked about in this course off the first go. I mean, chances are this is your first time seeing this information. So I don't reasonably expect you to memorize all of this information in only a 4 or 5 week timeline, and have an excellent mastery of it. All right. This is the first time you've seen more rigorous economic thinking. So I know it's a lot of information right now, but part of the reason for that is because it's my job to teach you guys all of these core economic principles. All right. These things, everything I'm teaching you, not all of it you might use in your studies, but I guarantee that there will be something in here that you will use in your studies. So you might not use it all, but all of your studies will use something. All right. Um, Let me go ahead and claim some space back right there. Can just erase that right there. All right. Actually, let me let me leave this. One of the things I wanted to say next was that let's look at this is essentially what we've covered here. today and what we will have covered by time for the midterm. And I I can level with you guys. Like some of the stuff is interesting depending on your interests, but a lot of it is some of the more boring stuff. We need to understand this first boring stuff to get to the fun stuff. All right. So pre-midterm, this is all pre-midterm. So I know the pre-midterm stuff can be a bit of a slog, can be a bit of a drag, can be a bit boring. I'm very aware. Um, we just need to have a solid grasp of these things before we can get to the fun stuff. All right. And what do I mean by the fun stuff? Well, what is coming next, what we will see after the midterm is the more fun stuff. We will see stuff like policy analysis. So now that after we will have completed the demand side, the supply side, and then bringing them together to get that equilibrium. Um, once we've established that at a higher level, then we can get to the fun stuff. So then we can start to look at market power and market structures. Then we can get to then we can get to taking a look at like how do we measure fairness? All right. For those of you that like public policy or that like legal type things or government type things, or even just generally like caring about like business landscapes, those are some things that we're going to look at when I talk about policy or welfare analysis. Um, Policy analysis or political economy is what it's sometimes called. And I know we have a major here at UW that concerns this. So this is going to be one way, one space where you're going to see this quantitatively, all right? Because I think the political economy major is a bit more qualitative. So we're going to see some of that quantitatively. Um, Further, we're going to see we'll get into game theory. We'll see a little bit of game theory and how do we use that to a more sophisticated sense in our economic models. Then we'll also see about risk and uncertainty. And then we'll see some behavioral stuff. And that's what will round off the course. All right. I think on the syllabus, I have to correct this because I think I put this first and then this second, but it flows better if we do game theory first and then leave the risk, uncertainty, and behavioral stuff for the end. Um, that's just how I think will the material will flow together better. All right. So that's what's coming post midterm. All right. Let me go ahead and just mark that to be explicit. This is everything post midterm. All right. So the exciting stuff is coming. All right. I promise you. I promise you the exciting stuff is coming. We just needed to get through this first half of the class to get to the exciting stuff. All right. We can't understand the fun stuff without first understanding the fundamental stuff. All right. So that's what you have to look forward to, and that's what I'm offering up to you guys as a motivation for sticking in there. All right, because again, I know I'm hitting you guys with a lot of information. Part of the reason for that is because my intermediate micro class, I took it during COVID. I took it the very first semester when COVID hit, when a lot of you guys were probably still in high school, and it was not that good. It was not that good because of it. It really felt like just another version of like your principles class. And that really did not do me well for my higher level studies. So my goal with this class is to give you guys all of this information to the appropriate level. And I'm not sitting here trying to test you guys on how much of a computer you are, how much are you able to recite. I just want you guys to understand this and like how this stuff is used at a more higher level. Like because people really do use all of these economic models. They use them in businesses. Businesses care about learning this stuff. Um, they use them in governments, whether it's government organizations or like not, they call them NGOs, non-governmental organizations, but it's going to be like IMF, it's going to be like think tanks, the World Bank, policy institutes. They look at economic models. The government cares about economic models. The legal industry cares about economic models. some of my professors back in Texas, some of their expertise had to do with like market power and whether somebody sufficiently had a monopoly or not, or like held a certain amount of market power. And so they would drag aspects of econ into litigation and either argue for or against whether some behavior is competitive or anti-competitive, so on and so forth. So all of this stuff has a use. All right, all of this stuff has a use case. It's just all the more important that you guys understand the fundamentals of all of this analysis first before we get to all of the fun stuff. All right. So that's what I want to say about where we're at and where we're going. All right. Great. And then everything else I think I can include in an announcement. I just have a few announcements on the homework stuff and then uh on some changes to the homework stuff. Not really changes, but just regarding deadlines, but we can leave that for an announcement. All right. So, yeah, with all of that out of the way, let's go ahead and get on to today's lecture. All right. Today's lecture is the second half of the supply side of things, second half of theory of the firm. All right. Second half of theory of the firm. So the last time we talked about, we kind of refreshed ourselves on supply from like principles level stuff. And then we talked about production. How do we model firms' behavior and how do we model the production side of what firms do? Today, in this lecture, we're going to look at the short run version of costs. That way we'll have gotten cost production in short run and cost in the short run. And then we're going to bring those things to the long run where things are more variable. Firms can choose more. And then we're going to connect the two. All right, we're going to compare the long run to the short run very briefly, just to compare and contrast the two. And this will wrap up the supply side of things. Um, and then next week, or in the next two lectures, I should say, excuse me. Then we will see supply and demand together. All right, then we're going to see equilibrium models. All right, so let's begin. So as I said, all right, we just finished production. All right, we just covered production in the short run. So now let's look at how we model costs in the short run. One of the things that we saw in the last lecture is that we like to model costs. We like to lump them into two groups. What are the costs of doing business for a firm? They're either going to face fixed costs or they're going to face variable costs. Putting these things together gave us our cost function. All right. And of course, your variable costs were things that depended on the quantity that you were producing. Meanwhile, your fixed costs were things that you paid regardless of whether you're producing zero, one, or a million things. All right. And that's how we shrunk all of this into this cost function. All right. And for an example, as a motivating example, suppose this sewing business faced a cost table like the one on your screen. All right. So they took note, they marked down um one, I should pre say preface with suppose they leased 5 sewing machines, and I like the word leased here because it kind of gets into what I mean with capital, because you don't often own capital, or if you do, it's deteriorating, like it depreciates, or often you're renting capital. All right, so I just use the word leased here. So the machines, they lease their machines. Um, and that's those are $10 each. They lease 5 machines for $10 each. And then they pay their workers $15 each. All right. So that's what this sewing business is doing. And they give us this cost table here saying at this many workers, this how many products. In this case, they sew dresses. This how many product I can kick out, how much product I can kick out. And then these are the costs at this level of labor that I'm employing and quantity of output that I'm seeing. All right. So this one first, this is an obvious, not obvious, but this is a first fundamental thing is, well, if I see variable cost and I see total cost, the difference between the two is the fixed cost. So it's going to be TC minus VC. And then I see if I just look at the very first entry in this table, I know the total cost is 65. variable cost is 15. So of course, the fixed cost is going to be 50. And then where is that coming from? Well, it's going to come from the 5 sewing machines for $10 each. All right. So those are locked in. All right. And that's an example of how capital is fixed in the short run. A very toy model of how we could say that capital is fixed in the short run. Um, but this is actually this is I'm not having you fill in a table here. What I want to show, what I want to lead off with is what does this look like graphically? All right. So we're going to draw two graphs. All right. We're going to draw one graph for production, one graph for cost. All right. So for production, let me zoom in just a bit more. For production, we have, or what I want to show is production. I want to show how much output can we kick out? How many products can we produce given these different levels of labor that we can hire? And if you, I'm not going to spend time plotting this super exactly. I just want to get the general idea of what we're going to see is that, remember, we change our number of labor here, a number of people that we hire, and here we see a quantity of output. And if you were to plot these points, then you would see something like this. All right. And that's the production side. But today's all about cost, right? So what is the cost? So on the cost side of things, I'm going to be looking at, on the cost side of things, you want to compare your cost, given these different levels of output, what do your costs look like? What do your cost functions look like? So here, what I mean when I say that is that to plot the cost, I want the dollar sign on the y-axis, and I want the quantity of output now on the x-axis. And if you were to plot the points in in this table, if you were to plot this on the x-axis and then these guys on the y-axis, what you would find is something like this if we were talking about total cost. And then we'd find something like this if we were talking about variable cost. All right. And then what about fixed cost? Well, fixed cost, what did we note up here? Fixed cost is just the difference between the two. All right. And here it's $50. But generally, fixed cost is just what is your total cost that you're incurring minus what are your variable costs? What are you paying? What are you having to pay to the things that scale with quantity? Graphically, the fixed cost is represented by all of this space in between. So this gap, all of this is your fixed cost. All right. So that's just some motivation for what we're going to be looking at today. All right. Last lecture was all about production. Today we're going to be looking at costs, and then we're going to bring the two together in the long run, and then we're going to connect the long run to the short run. All right. So a subtle modeling detail, what did I just point out up there? Is that for production, we had labor on the x-axis, quantity on the y-axis, or output on the y-axis. For cost, then we had quantity on the x-axis, and we had it had you could either do, I want to just say a money amount, a dollar amount on your y-axis. You could also see labor on the y-axis. All right. So generally, the idea here is that they're kind of flipped, right? If I'm talking about production, then labor goes on the on the x-axis horizontal, and your quantity of output goes on your y-axis. Meanwhile, for cost, your quantity is going to be the x-axis, and your dollar amount or your labor employed is going to be on your y-axis. But I think the dollar amount is better. All right. Further, we had these metrics for productivity in the last lecture. We talked about marginal product. Um, Marginal product of labor, marginal product of capital, all these marginal products and average product. We can do this same type thing for costs, all right? So this is pretty simple, right? So what is average total cost? Oh, this is a typo here. Let's go ahead and get this one out the way. Average total cost. I'm going to fix this on the document. But the average total cost is simply your total cost divided by quantity, all right? How much on average is your total cost per unit? All right. And you can do the same thing with the other cost. So you can have your variable cost divide by its quantity, by the quantity of production, and you can have your fixed costs divide by the quantity of things that you're producing. All right. So you can take averages for costs. All right. Nothing too groundbreaking there, but they do become important. But they're very easy to calculate. You can also do marginal costs. All right. And I have noted here that marginal cost is how much does our cost increase when we produce one more unit. All right. Specifically, what I have written on the screen is how much does our variable cost increase when we produce one more unit. All right. Why do I say only variable? Well, fixed costs. All right. Why do we not care about them? Because they're fixed. Fixed costs do not change with different units. Fixed costs do not change with output. Thus, another way you could say this is that your marginal fixed cost is always zero. All right. So when we're talking about marginal costs, we usually we're actually always looking at how does our variable cost change when we change our output. All right. So what does this look like? Well, if that's the case, your marginal cost is your change in total cost with respect to your change in quantity. But we know that if we decompose total costs, we have variable costs and fixed costs. And fixed cost does not change at all, so that thing goes away. So you just have your change in variable cost with respect to a change in quantity. And then what are your variable costs? Well, your variable costs are it's the price. Remember, in the short run, let me write this out. What are your variable costs? Well, in the short run, we assume capital is fixed. All right. So we really only consider changes in the cost of labor. So the change in variable cost is the change in your wage times the amount of labor that you employ with respect to quantity. And why is this? This is because, let's write it a little bit cleaner. Because K is fixed, at least for right now, in this simple the way I'm introducing it to you, we just assume capital is fixed in the short run. All right. And so really we're looking at the change in labor cost, right? Well, in the short run, you can't change how much you pay somebody. All right. If we're only considering the short run, then your wage, that W, is a constant. So really, this is W times the change in labor divided by the change in quantity, or with respect to the change in quantity. All right. All of these things are how we can express marginal cost. All right, different ways to express the same thing. All right, the notion of equality. So, given the same example as before, now let's look at how these things are calculated with the in table format. All right. So this is the same example as above. Now I want you guys to take a few seconds, pause the video right here. This should take like 5 minutes or less. Just fill in this table. Fill in this table. Um, I want you guys to just make sure you're cool with calculating your average fixed cost, your average variable cost, average total cost, and you should know what your marginal cost as you go from unit to unit is. I also left this blank space for the marginal product because I have total product and I want to illustrate how does our output change as we hire more and more labor. All right. So pause the video right now, take a few moments and fill out this table, and then we will return. All right. So I hope you're able to fill out the table with not too much trouble. All right. And the point of this exercise is not to prove that you can divide things. It's more to so that you can do this on your own. And I want you to see if you notice things. See if you notice things that you were already introduced to in Principles of Micro, but now actually seeing it at a little bit more detail. All right. So what you should have found is something like this. All right. This is what you should have found for your marginal product, and this is what you should have found for the cost side of things. So let's take a bit of notice of what do we see. From left to right, we see our marginal product. We have a point to where as we hire more labor, they kick out more marginal product, right? From 0 to 1, the marginal product is 5. So that first laborer, he brings 5 extra things. He increases our output by 5 extra things. And then from 1 to 2, marginal product is 7. Second laborer made life a lot easier. Now we can kick out more stuff. From 2 to 3, same deal, makes life easier. All right. Now instead of just 7 more things, we're kicking out 9 more things. That third person's kicking out 9 more. Then we see, what do we see? This dividing line is just for this product category, column, I should say. After we hire 3, this is where marginal product is at its max. All right. Because going from 3 to 4, we see diminishing marginal product. From 3 to 4, we see diminishing marginal product. All right. So we see diminishing marginal product. At first, hiring more people allowed us to produce more things, up to a tipping point. And then we see that after a certain threshold, for once we hire that third person, when we go from 3 to 4, the marginal product, the marginal value add starts decreasing. All right, we go from 9 to 7 to 5 to 3, and then to 1. All right. This is something we kind of saw in Principles of Economics, Principles of Micro. Um, and this is just seeing it in table form. And this is what a firm is going to consider when they're making the business decisions that they do, when they're considering how many people to hire or how many people or where should we stop. All right. If we come over to the cost side of things, let's look at the cost side. First, we have our average fixed cost. So fixed cost does not change. All right. As we hire more workers, it's still the same fixed costs. In that sewing example, you're still paying $50, whether you had only one worker or if you had 7 workers, all still $50. So we notice that as we increased labor, our fixed cost, average fixed cost. So remember, what is the purpose of taking an average? It's to get a grasp, just get a quick measurement of like a per unit basis. All right. So per unit, when we only have a little bit of labor, when we only have like 1 or 2, that fixed cost, when we look at percentage of the total cost, that fixed cost accounts for quite a lot. All right. 10 average, like per unit, you're paying in fixed costs is $10 when you only have one laborer. But as we hire more and more labor, that fixed cost kind of gets washed out. All right. It's not so expensive after a certain point to for those machines. What becomes more expensive is the labor cost. All right. So fixed cost is strictly decreasing, or average fixed cost, I should say, excuse me. Average fixed cost is strictly decreasing. All right. The same cannot be said for variable costs. Because what do we notice? We notice that as we hire one worker, our variable cost starts at 3, and then it does decrease. It does decrease up to a point. Up to a point. We see that at 3 workers, our average variable cost is 2.14. At 4 workers, it's the same. But after that fourth worker, the average variable cost starts to come up. All right. Another tipping point. All right. So we see that average variable cost is not monotonic. It's not strictly decreasing. It decreases and then it starts to go up. All right. I will show this in the graph in a second, but it decreases and starts to go up. And then what do we notice? The same thing for average total costs is the pattern is the same. These guys share a similar pattern. We see that we see that although it occurs at different amounts of labor, we see that our average total cost, as we hire more labor, first, for the most part, it starts to go down, starts to go down, down, and down. But there's another tipping point. There's another tipping point where after a certain amount of labor that you hired, your average total cost is going back up. All right. So we also get this inverse U or this U-shaped behavior. All right. It decreases, decreases, decreases until it doesn't, and it starts coming back up. So average total cost, because of it being composed of average variable cost, is also not monotonic. It's not strictly decreasing. It has a tipping point. Again, what about for that marginal cost column? Well, what do we see? We see that marginal cost is small to begin with, and it actually decreases up to a point, and then marginal cost starts increasing again. All right, until it gets very large. All right. So this should remind us of something that we saw in Principles of Economics, right? That um we see that something there should be, maybe we can't see it exactly from this table, but you should start to get ideas of like, costs change depending on how much we hire, and then how much we hire has an effect on our output, that quantity. So maybe there was a word for that. I don't know if we can exactly see it here, but I think there was a word for that from Principles of Micro. So if that's starting to ring any bells, keep those in mind for the later part of this lesson. All right. That's how you should fill out a cost table like this, and those are the implications of, or those are what all the tipping points mean. All right, we see some monotonic behavior, but for the most part, we see non-monotonic behavior. All right, and then so what if instead we knew the cost of an additional unit of labor? Because what is that cost? Sorry, there was something on the screen. Because what is the cost of an additional unit of labor? Well, it's just the wage you're going to pay the worker. And instead, what if we want to figure out what is the marginal cost of the next unit of output? This is where we have that marginal cost is equal to, remember we said that this was equal to the change in variable costs with respect to change in quantity, which was the same as saying change in W times L with respect to quantity, change in quantity. It is the same thing as, well, yes, yes, yes. What I'm going to do, we know that this was this times this, because W is fixed, the wage is fixed in the short run. Can't change somebody's contract in the middle of the contract, right? This is the same thing as change in quantity divide by change in labor, all right? Because to divide by a fraction is to just multiply by its reciprocal. And this is simply your wage divided by, what is that bottom right there? What is this right here? This is your marginal product of labor, all right? How does quantity change with respect to labor? This is actually what we saw in the last lecture with production. This is the marginal product of labor. So if we knew the wage, right, this is what I have written here, is that if we knew the wage W, then we can calculate marginal cost. We kind of reverse engineer it. All right. So your marginal cost is equal to your W divide by your marginal product of labor. Then I make a note here that there's an inverse relationship between marginal product of labor and the marginal cost. Let's do that one. All right. Because what do I mean by that? It means that, well, if I'm only looking at this and this, then as the marginal product, the thing on the denominator, as that thing gets bigger, then your marginal cost gets smaller. On the other hand, if marginal product is getting smaller, then your marginal cost is getting bigger. Easily put, MC goes up as MPL goes down. All right. And vice versa. So that's one way that we can kind of reverse engineer marginal costs if we just know the wages and how our output changes. All right. So this gives us a few different metrics for measuring costs and production. Um, we saw the production last time, and now we see the cost this time. So let's look at a few relationships between the two, just to cap this off. All right. So marginal cost and marginal product of labor, this is what we just saw above, that there's an inverse relationship between them. All right. Let me see. How did I have it organized? So marginal cost and marginal product of labor. Let me just say that we have inverse relationship. All right. The idea, the idea is that, let's see. I'm going to write these things on the next page. All right. So first, looking at marginal cost and marginal product of labor, we had this relationship that marginal cost is equal to, we have this identity that it's equal to wage divided by your marginal product of labor. And so graphically, what we would see, what we would find is something like this and this. And let's move this one over just a hair. All right. And if I were to put marginal product of labor on the top, I want to count or I want to graph how does my marginal product for labor change as quantity changes? Or I should say that, how does quantity change as we hire more labor? And that's how we get quantity on y-axis, labor on l-axis, x-axis, excuse me. This is our marginal product of labor. And if they have an inverse relationship, then these things are going to have essentially the opposite shape. So if that's that, then when we're graphing marginal cost, then we're going to see something like this. All right. So the marginal cost and the marginal product of labor have an inverse relationship, and they relate in this way. Next, we talked about total costs and then total variable cost and total fixed cost. We know that total cost is equal to total variable plus total fixed cost. And then we saw that one way to express this graphically was if we had this being our total cost function, then your variable cost function traced exactly that, but it was shifted downwards. All right. So this was TC and this was VC. All right. And then we know that the difference between the two, that gap is the fixed cost. Or if we were to plot this, or another way to express the fixed cost is that it's just this intercept, the intercept that the total cost curve starts at. And that's the relationship between these two things. All right. The total cost is the sum of your variable and your fixed cost, and your variable cost is what changes with output. Your fixed cost does not change with output. All right. Lastly, if we're looking at average total cost, average variable cost, and average, like all the averages, fixed cost, and then relating it to marginal cost, what do we find? That's where I think I can use this one up here. Um, we see something like this. All right, we see something like this. Remember that. Remember that. Um, this was, let's see, let's see. Let me put this. I guess I should put this down here. All right, this is what I gave us the space for. All right. All right. So down here, um, on the last on the last lecture when we talked about production, we saw this relationship between marginal product and average product. We have this same relationship between marginal cost and average variable cost. All right. And when I say that, I mean that marginal cost and average variable cost intersect, they cross at the bottom, otherwise known as the minimum of the average fixed cost curve. I'm sorry, average variable cost curve, excuse me. Average variable cost at the bottom of a VC. All right. And so what I mean by that is that if we have marginal costs, remember from the table above, we saw that marginal costs had this non-monotonic behavior. So we saw something like this for marginal cost. And average variable cost, that is, also had this non-monotonic behavior. And that one looks something like this. All right. Something like that. And just suppose that that's about its minimum. All right. Not to scale, but roughly that is the minimum. All right. And then always label your axes. This is dollar sign, that's how much in dollar terms, and this is quantity. So we have here, let me do a straight line. Do this. So at this intersection, this is where average variable cost is at its lowest. And that happens when marginal cost is equal to average variable cost. All right. Um, to the left side of this, well, visually, what do we see? Remember, this top curve is variable cost. So this line right here, I said top curve. I should be a little bit more specific. This line right here is variable, and this cost right here, and this line right here is marginal. So to the left of the minimum, we see that um, average variable cost is greater than the marginal cost. All right. And then to the right of the minimum, we have that average variable cost is less than the marginal cost. All right. Um, to the left, we see that our variable cost is rising. All right. And then to the right, we see that our variable cost falls. All right. Or at least um, in relation to marginal cost. Now here, I've drawn this curve for you, and I have a little bit nicer picture here that I didn't end up using. But look at this. Take a look at this picture. You guys understand all of this now, right? You guys understand now with these explanations, with taking this class, with seeing these notes. Why do these curves have this shape? All right. Now I want to, this is kind of where I want to circle back to remember what I said was one of the purposes of this course is to see things that we saw in principles of micro, but at a higher level. So now you guys know why these curves have the shape they do. Well, let's look back at what did we see in that lecture one when I was trying to give you guys a refresher. I had this graph right here, all right? And what do we notice, guys? What do we notice? We have the marginal cost curve right here. We have our average total cost curve right here. We have the average variable cost curve right here. And they have the exact same shapes that we just saw, that we were able to construct, all right? That is how your principles of micro professors were coming up with these graphs, or the textbook authors were coming up with these graphs. They're not out of nowhere. These graphs encompass or it capt they capture this behavior that we're trying to model of firms. One last thing too is remember, so now Of course, over here, oh, this one has it too. So down here, I gave just in, no, I did it regularly too. So we had marginal cost and average variable cost. Up here, this one plotted the average cost as well, not just average variable cost. And then back here, this one is average cost as well, right? Total cost. And this one was average variable cost. What did we notice from that cost table from like 10 minutes ago, whenever that was? All right. The average fixed cost was always decreasing, right? So the average fixed cost was always decreasing. So if this is your average fixed cost, we see that the average fixed cost, remember, it's getting smaller and smaller. All right. So that is how, that's why we see these curves coming closer and closer together. All right. Because when we're talking about averages, that denominator is quantity. So the denominator is getting bigger and bigger and bigger, but your fixed cost does not change. And so that average fixed cost is getting smaller and smaller and smaller. And then those curves are getting closer. These curves are getting closer and closer together. All right. So I wanted to include that bit to show you guys that these things were not just coming from nowhere. All right. These graphs actually tell quite a lot of a story. And the details are sometimes so subtle that you might miss them if you didn't know what to look for. All right. So this is just one way in which that the stuff you're learning today actually loops back and reinforces what you learned in Econ 200 or wherever you took principles of micro. But now you know where these things come from. Now you know why they got these crazy looking graphs. All right. And that, in essence, summarizes everything that I wanted to say about costs in the short run. All right. So now, next, let's move on to cost, production and cost in the long run. Actually, really quickly, I just want to add one more thing. That, of course, MC and AVC intersect at the bottom of AVC. It's also true. I won't bother drawing it here, but it's also true that MC and your ATC also intersect at the minimum of the average total cost. All right. Now, now we're ready to move on to the long run. All right. So now we're shifting our focus to the long run. All right. So let's recall the same production function that we saw in the last lecture. All right. Yeah, it's 3 times L times K. All right. Elk. All right. Just as a motivating example, what do we see? Well, we know that here in the short run, we would assume that capital was fixed. And so here in the short run, we would assume that capital was fixed. Meanwhile, in the long run, we can change both labor and capital. So what I was drawing here on the table was that in the short run, I could only move left or right, right? Left or right. I could not change my amount of capital. I can only move within the row. All right. Sorry, I can move between columns, but I'm stuck in that same row. All right. On the other hand, in the long run, I can move up or down and left or right. So I can move within columns and within rows. All right. And so the short run is the red. Meanwhile, the long run was in the blue. All right. This is the essence. This is the essence of the difference between the short run and the long run. And so when we're thinking about the long run, the one of the questions we want to answer is how do firms choose how much capital or how much labor they want to employ? Well, they're going to consider two things. All right, they're going to consider two things. They want to choose a combo. They want to choose some combination that produces some desired level of output. All right. So we notice that a combo of 5 capital and 6 labor gives a quantity of 90. And we notice a combo of 6 capital and 5 labor also gives a quantity of 90. All right. So they want to hit a certain quantity. That's priority number one. And then priority number two is that they want to minimize costs, all right? Because when you're minimizing costs, you're maximizing profit. All right. It's two sides of the same coin. And this will actually reappear. This will actually be a recurrent theme through this lecture. All right. So this is what a firm's goal is to do. This is how we do it. This is how we set up our models, and this is pretty realistic, right? Firms are more rational and more computer-like. Businesses are more like computers than people are. All right. So I always found that the production side, this stuff is very believable. All right. Doesn't take too much convincing. So how are we going to look at this? How are we going to model the firm's problem? Well, I just want to give a preview, is that the firm's problem is that you either have the profit maximization problem, either max profit, and I'm going to write this later as well, or we will see this later as well, but just a preview. We either model the firm as maximizing profit or minimizing costs. So you want to minimize costs. All right. These are two sides of the same coin. They accomplish the same thing. Um, it's just the way we choose to set up the firm's problem is really dependent on what things we want to look at more. All right. Now, remember for the consumer, we had a utility maximization problem, right? They wanted to max utility. And they did this, or two of the tools that we used to do this were an indifference curve and a budget constraint. All right. Well, here we have an ISO quant curve and an ISO cost curve. All right. These are going to be the exact parallels, the exact analogs for the firms as what we saw for the consumers. All right. So the ISO quant is all combinations of inputs that produce the same level of output. All right. For the consumer, we had the indifference curve. All right. For the consumer, we had the indifference curve, which was all combinations, all bundles, which give the same level of utility. All right. And these were our curves. These were the true curves. Meanwhile, let me go ahead and combinations of inputs that produce same level of output. All right. And that's the ISO quant. On the other hand, you have the ISO cost. And this is going to be more analogous to the budget constraint. All right. The ISO cost is saying what all combinations of capital and labor cost the same amount. All right. All combinations of inputs that cost the same amount. And this is like the consumer's budget constraint. Because remember, we had combinations of things that we could buy given a certain budget. All right. All bundles that can be bought given some amount of money, our budget. All right. This is what the ISO quant and the ISO cost curves are. All right. So first, we're going to look at and define specifically the ISO quant curve. All right. So ISO quant, remember, it's all combinations of K and L, all combinations of our inputs that produce the same level of output. All right. So whether I'm right here or I'm right here, doesn't matter. I'm producing the same quantity. All right. I'm producing the same quantity. The ISO quant curves, they have the same properties as indifference curves. All right. ISO quant, they're always downward sloping. They never cross due to transitivity, a property of transitivity that was maybe referred to in the lecture number 2, but they never cross. Um, all of them produce the same level of output, like what I just said, whether I'm here or here, you're producing the same level of output. That's the name. In the name is ISO, means one. Quant means quantity, right? I think ISO might also mean like same. So ISO is same, quant is quantity. So same number of output. And then mathematically, because in theoretical economics, when we're doing just pen and paper and not data, um, we care about, is the function convex, concave, some combination, or what? So for isoquants, these are convex functions. So they're decreasing. So the derivative is negative, but they're getting flatter. All right. So they're decreasing, but the sign, the magnitude of the slope is decreasing as well. So they're decreasing, but the slope is the first derivative is also decreasing. And then if you read economic textbooks, they will use what's called the unit isoquant. And all this is just an isoquant that corresponds to one unit of output. All right, unit isoquant is just all K and L, uh, all combinations K and L, which produce one unit of output. All right. Now, next, if you recall, the consumers had the indifference curve. All right, the consumers had the indifference curve. They had an indifference curve, and then the slope of your indifference curve, what was it? It was the MRS. All right. It was the marginal rate of substitution. Well, firms, they have an isoquant curve, and instead of MRS, we have MRTS. All right. The marginal rate of technical substitution. Why is it technical? Because these are technological inputs. All right. So the isoquant curve has the slope of the isoquant is your MRTS, or your marginal rate of technical substitution. All right. But aside from just being a slope, what does this represent? All right. This math is fun and cool, but it means nothing if it doesn't map to the real world. All right. So what does the MRTS represent? The MRTS is how much I should point out. Remember, we have capital on the y-axis and L labor on the x-axis. So this is equivalently dy dx, or this is dk dl. All right. If we were to write it in like derivative notation. But what is this? What is the interpretation of this? Like the real world mapping? Um, e- Economically, it's how much capital you need to hire to replace one laborer and still maintain the same output. All right. It's how much K. Sorry, give me one sec. All right. I think maybe I misspoke just a little bit. I said higher capital. How much capital you need to employ. Actually, I should say this backwards. I should say this backwards. How much L you need to hire, how much labor you need to hire to replace one unit of capital K. All right, sorry. We're gonna back this up a little bit. I'm gonna rewrite this. I think I had written this wrong on my notepad here. All right. So economically, it's how much capital K. I said it right the first time. I wrote it wrong the first time. All right. It's how much capital K you need to replace one unit of labor. To replace one unit of labor and maintain the same level of output. All right. Yeah. Because here in this diagram here, all right, to replace, like if I go from A to A prime, to replace that one unit of labor, I need to increase my capital by such an amount, by a delta K. All right. And so that is the interpretation of the marginal rate of technical substitution. All right. The MRTS slope of the isoquant is how much capital do I need to replace one unit of labor? All right. And still maintain the same output. To maintain the exact same output. And then up here, I just want to add, that's one bullet point. Second bullet point, we for notation, MRTS LK, we write it in this way if we wish to denote replacing L with K. All right. And then one thing, remember one thing here, um, isoquant is the same quantity. All right. And then just one thing that I think this might not, you might not care about this. But if the order of what is on the numerator and what is on the denominator is bothering you, then then just remember this is a change in quantity with respect to the change in labor divided by this change in quantity with respect to change in capital. All right. And so those Q's, delta Q and delta Q will cancel out, and they will bring us back to over here. And that is why the interpretation is this way. All right. Because we were replacing labor with capital. All right. And that's why we have that interpretation. All right. Great, 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 great. And then that's just the interpretation of the MRTS. All right. In other words, the simple takeaway, the TLDR, is that MRTS is equal to the negative of the slope of the isoquant. So it's the negative of the delta K over delta L. Because this thing already is negative, and so we throw a negative sign in front of that to get a positive number. To say like, okay, if I'm firing one guy, how much more capital do I need to employ? All right. And I need a positive number there. I can't employ negative capital. All right. And then with derivatives, we saw that, okay, that's the same thing as saying dk dl. And that's also the same thing as saying the negative of dq, not Dairy Queen, but dq dl divided by dq dk. And not DK Metcalf either. I know he ain't around. But I'm a Steelers fan, so I'm still pretty happy with that. But and then also, between any 2 points on isoquant, I want to make note of two things. That first, between any 2 points on an isoquant curve, that the change in unit of labor is replaced by a change in unit of capital. So I should say that the change L in unit of labor, you have some delta L unit of labor. Labor changes by, um, how do I want to say this? Let me actually, so let me write it this way. Changing L by delta L units, and we're changing K by delta K units. All right. Because remember, marginal rate of technical substitution, we're switching technology, we're switching which inputs we're using. So we're changing L by delta L units, and we're changing K by delta K units. And this maintains the same quantity of output. All right. Um, so on one hand, output decreases by your change in L times your marginal product. Oops. Let's do this. Your change in labor times the marginal product of labor. Because how much labor am I firing? times how much was each of those guys helping me produce. So output decreases by this much, but then it also increases by what the capital, what the machine is doing, is bringing to the table. So output simultaneously increases by your delta K times your marginal product of capital. And these things do not change the quantity of output, and so these should be zero sum. So, so because output does not change, then we get this relationship that delta L times the marginal product of labor plus delta K times, let me clean that one up, delta K times the marginal product of capital. These two things cancel each other out, and so this should be zero. All right. So this should be zero. All right. From that, from that, if delta L times the marginal product of labor plus delta K times the marginal product of capital is equal to zero, then this tells us that let me move this over to this side. So delta K times the marginal product of capital is equal to the negative of delta L times the marginal product of labor. And then let me divide by delta L. So I have that delta K times the marginal product of capital. I'll divide by delta L by the negative of delta L is the marginal product of labor. And then finally, let's divide both sides by that marginal product of capital. So we have that your delta negative of delta K divided by delta L is equal to the marginal product of labor by the marginal product divided by the marginal product of capital. And now, what did we just see up above? That on the left-hand side, that exactly is the MRTS. All right. And then we have this alternate expression for it, that this is the MRTS of L4K. All right. And then, like I said, this is change in quantity with respect to change in labor, divided by change in quantity with respect to change in capital. So a tiny, tiny preview of some analysis, if you will, some proofs, baby proofs, but still proofs. Give us some nice results, and we get these nice relationships, these nice identities. All right. All of this to say that there are the two ways to calculate MRTS. All right. You could either take the change in capital divided by the change in labor, or you can take the marginal product of labor and divide it by the marginal product of capital. So we have two ways to compute MRTS. All right. And then that's what I have written here. Great. So for example, suppose you had a problem like this, all right, that if output's 100 units and currently K is 2 and L is 3. So currently K is 2, L is 3. Tells us that we should be right here. I think this is backwards. I'm gonna fix this as well. So I think K should be 3 and L should be 2. So I'm gonna fix this on the document. So K is 3 and L equals 2. Then, then we are in the right spot. So K is 3, L is 2, so we're right here. All right. And then, so you're right here, we're in the yellow square, and they ask you, I ask you, what is your marginal product of labor? What's your marginal product of capital? And what is the MRTS? Well, how would you do this? How would you do this? You can take a sec, pause the video if you think you have an idea, and try to write it below. If not, let me show you. All right. So first, your marginal product of labor is equal to, well, how you're going to do this is you're going to say, okay, well, from 2 to 3, if I go from labor at 2 to labor at 3, sorry. Um, yeah, I wrote this a bit backwards, and that's a little bit unfortunate. That's okay. That's okay. Um, yeah, this is okay. I see what I did. I see what I did. So I have a bit of typo on our notes. I have a bit of typo on our notes. So what we're gonna do, if you're seeing this video, by the time you see this video, these things will be fixed. So just fast forward right here real quick. But what I'm gonna do is I'm gonna erase this, and this was actually correct. What I did wrong and that I need to correct, I'm gonna probably highlight it so that I remember it, is that this should have been capital. So this is capital, and then this side is labor. So that's what I copied incorrectly from my notes onto my scratch pad here. So this is capital, and this is labor. And that's why what I had up here was correct. That if capital is equal to 2, labor is equal to 3, we're at 100. All right. Now we may proceed. Sorry about that. So what is our marginal product of labor? This is where I spotted my mistake. I To get the marginal product of labor, we go from 2 units of labor to 3. How did our product change if we just suppose capital was fixed here? Well, your marginal product of labor at this point, we went from 80 to 100. And so that marginal product of that third unit of labor is 100 minus 80. What did that third guy bring to the table? He brought 20 extra units. Next, what was the marginal product of capital? It was the same thing. All right, the same way. You want to calculate this thing in the same way. Well, from what is the marginal product of that second machine? All right, the second unit of capital. When we went from 1 to 2, our output increased from 70 to 100. So your marginal product of capital is going to be 30. All right, it's going to be 100 minus 70, which is 30. And then putting these things together, your MRTS is equal to, remember we had it as the MPL divided by the MPK, and this is 20 over 30, and this is simply 2/3. And that's how you would answer a question like that. All right. So I'll correct the typos on the document that you see on Canvas, but this is how you would answer a question like that. So that's all about isoquants, all right? And that was, remember, isoquant was analogous to the consumer's indifference curve, all right? Now let's look at ISO costs, all right? This should be analogous to the budget constraint, all right? Cost is like a budget, all right? You got to stay within the same cost, so you got a budget. So it's combinations of K and L that give the same cost, all right? So how do we model a firm's costs? How do we model, if we're only talking about labor and capital? Well, then clearly your total cost is what is the price of labor times how much labor you're using, plus the price of capital times how much capital you're using. All right. But what are these prices? Well, alternatively, we can express this as the wage that we're paying each of our guys. And then what is the price of capital? It's going to be the reason I used lease earlier is because you lease at an interest rate or you need a loan for capital. And so what is the price of capital? What is the price of the loan? It's an interest rate. So it's going to be an interest rate R. And we're just assuming they all have the same wage and they all have the same interest rate for now. Um, but models can be enriched by assuming that these things different. You could have different wages for different workers. You can have different if you're a finance major or a business major, then you know about cost of capital. And so you know that sure we might do like a weighted average cost of capital, right? A WACC, or but actually different capital has different interest rates. All right. But for now, we're just trying to get a basic mathematical framework, so we just assume interest rate R is the price of capital. All right. And just like the budget line, well, the ISO cost is just a line. It's just a straight line. Your ISO cost, let's put capital K on the y-axis because we need this to agree with the above, and labor L on the x-axis. So if we only employed capital, remember we have a certain budget. I'm the firm, I'm the business, you're the business, and you have to stay within budget. All right. And you have to choose how much capital do we want to use and how much labor do we want to use. All right. If I want to use all of capital, then I'm going to say, okay, given my total budget, I'm going to spend that all on on capital. That's going to be the price of capital, and that will give us one intercept. On the other hand, if you take the other extreme and say, all right, I got a certain budget, let's just only employ people, let's not rent any capital. So you have whatever your total cost that you're trying to work with is, and you divide it by the price of labor, which is the wage rate. The line that connects the two, this is your ISO cost curve. All right. So the labor, the x-axis intercept is your cost, your budget divided by the price of labor, your wage. The k-intercept, the y-axis intercept, is your total cost or your budget divided by the price of capital. And then the slope, all right, is the negative, all right, the negative of those two prices. Um, and so we get negative PL divided by PK. In other words, negative of the wage rate divided by the cost of capital. All right. And I have on here interpretation. Um, Let me give us some extra space. I should say that the slope, when I'm asking for the interpretation, that the slope, negative W divided by R, is the rate at which labor can be substituted for capital with no change in cost. Rate at which labor can be substituted rate at which labor can be substituted for capital with no change in cost. All right. This is the equivalent, this is the analog of the firm's budget constraint. We call it an ISO cost curve. All right. We don't want to trip wires. So we got indifference curve and budget for the consumer. And we got ISO quant and ISO cost for the firm. All right. But they have this very nice symmetry. All right. These problems are kind of set up in the exact same way um, to make life easier. All right. So that's all I wanted to say about strictly focusing on the long run. Um, it does go deeper, but I think given the time constraints of this course, that's all I want to introduce you for those two things. Um, Now let's consider, how does a firm make its decisions for the long run? All right, how does a firm make its decisions for the long run? This is what I alluded to earlier, was that on one hand, you can view this as a profit maximization problem where you choose some quantity Q that maximizes profit. Go ahead and underline it. You choose quantity Q to max profit subject to costs. All right. So in this version of the problem, you're choosing quantity, you're choosing your output to max profit, and your constraints are your costs of your inputs. All right. On the other hand, you could explain this exact same problem, but through the lens of cost minimization. All right. In this way, you're choosing K and L, which minimizes, yeah, which produces a quantity to produce a certain quantity of Q, and I should add, and minimizes cost. All right. Two sides of the same coin. This is the exact same problem. Um, we're going to look at it through the lens of number two, but how you want to set up this problem or how an economist wants to set up this problem may change depending on what things they want to model or what things they want to capture. All right. And so how does the firm make the decisions that it does? Well, it says, I want to target a certain level of output, and then it looks at the inputs that it needs to get to the output and says, all right, which of those, what combination of those inputs minimizes cost? So that's why I think the number two is preferred to introduce this. But if you go into higher level econ, I think they like number one a little bit more. But it really doesn't matter. They're the same problem. It just depends on what things you want to capture. All right. So first, the firm determines what output they want to use, and this gives us the ISO quant because all of these combinations give us the same output. And then they want to determine what is the point of lowest cost. All right. So a nice little geometric interpretation is that for the cost minimization problem, this ISO quant, once they determine how much they want to produce, doesn't have to be super perfect. It's fine. So this, the ISO quant curve, this is fixed, and they're going to choose um, what combination of inputs, what combination of inputs give us that amount of output, but at the lowest cost. And that's why I say moves the ISO cost, because this is the idea, all right? As I switch the inputs that I'm using, um, this is moving the ISO cost left and right, all right? And I need to get it to where it's still hitting the ISO quant, but at its lowest point, all right? Because to the left is cheaper, to the right is more expensive, all right? And then I have it down here. Um, But let me just say a few. This is what I was drawing up above. But this is the idea. If like for this example, if we know we needed to kick out, we need to produce 2 units, then I'm gonna look at um what all combinations of capital and labor can produce me 2 units. Um, and that's the ISO quant. And the ISO cost is just saying, okay, well, given these prices, um, um, what does the budget look like? What does the firm's budget look like? But to solve this problem, before I go down below, to solve this problem, at the optimal, what do we notice? At the optimal, what do we notice? Let me, this one, that's fine. Let me gain this space back. I don't want to clog muddy up this page. So the optimal solution for the firm is where the slope of the ISO cost is equal. This should say typo again. Many typos. I apologize for that. Many typos. There was a lot in this lecture. Where is optimum for the firm? It's where the slope of the ISO quant is equal to the slope of the ISO cost. All right. In other words, it's where the MRTS is equal to the price ratio of the inputs. And a consequence of this is that the marginal product of labor is equal to the marginal cost of labor. All right. So that is optimum. That is the optimal point for the firm. And this should look very familiar to you, right? Maybe something like demand side of things. Right? Visually, visually, this is what's going down. All right. Visually, this is what's going down. All right. We know we need to kick out 2 units. And then we have to determine um, how much money are we going to be spending to kick out the 2 units. Well, if we were to say, well, how about we go to point A? All right. Because point A, all right, pop quiz. All right. Does A kick out 2 units? Yes. A will produce 2 units. Does D kick out 2 units? Yes, it does. So A and D both produce 2 units, but one is going to be cheaper than the other. All right. Um, how do we know which one is cheaper? Well, A is on this ISO cost. Meanwhile, D is on this ISO cost. So to the left is cheaper. So for sure, D is cheaper than A. So we don't want A for that reason. Additionally, Additionally, what do we notice? At point A, this slope of the ISO quant is steeper than this slope of the ISO cost. Very similar results to what we saw, right? At this point, at point A, the MRTS is steeper, the slope is steeper than the price ratio of inputs, which is PLPK. What does this mean? At this point, the marginal value is greater than the marginal cost. And so this means a firm could still improve their productivity. Productivity. All right. And how do they improve productivity? They could increase labor. All right. They could increase labor, right? Because a nice graphical interpretation. All right. The slope, remember the slope of the budget, whether you're talking about a firm or a person's budget, that slope is constant. All right. But if we're looking at for the consumer was the IC, for the firm, it's the IQ. All right. This slope decreases as we move to the right. And as we move to the right, we're hiring more labor. So to move to increase productivity, we want to move to the right, we would increase labor. All right. Conversely, if we looked at point D, all right, if we looked at point D right there, at point D, we have the reverse is true. That here, the MRTS is I had to make sure I wrote these things right. Don't want to steer you guys astray. Here, the MRTS is less than the price ratio of inputs. All right. Because graphically, now the slope is very flat. Meanwhile, the slope of the budget or the IC, the ISO cost, is the slope of the ISO quant is flatter than the ISO cost. All right. And so then they want to move to the left. We're hiring too many folks and we need to add some machines. Right. Cut a man loose, maybe cut a couple men loose. All right. And then you gotta add more machines back. So here, it's the exact reverse of the scenario above, in that the marginal value of labor is now less than the marginal cost of labor. And I should have put the subscripts. All right. And then what does this mean? Firms should cut back on labor. All right. And of course, what is the optimal? The optimal is where these things are tangent to each other. All right. The optimal is at point C. The optimal is at point C, where these things are tangent to each other, where the IQ, isoquant, has the same slope as the IC, the iso cost. And here, MRTS is equal to the price ratio of the inputs. All right. And that's optimal. That's where the marginal cost of labor is exactly equal to the marginal value of labor. And that's where this is optimal. All right. So with that, that is how we model the firm's problem in near identical fashion to the consumer's problem. All right. To introduce this framework for decision making. And like I keep saying, I kind of think that the firm's side of things, the supply side of things, is even more realistic because firms are right? We are people. We are not perfect calculators. But firms, that's a collection of people. And you've got people watching all these decisions, and firms are not so loose to spend money, at least not for very long, and so they will correct things very quickly. And so this I always found that this is even more believable than the demand side of things. The supply side is actually very realistic in my opinion. All right. So that's how a firm makes this decision. That's how we want to model the firm's problem. Now, the couple last things that we want to talk about, I just want to make note is that remember up above, we only specified one level of output right here, right? We specified that we only wanted 2 units of Q, and then we found that point C was the optimal, all right? But what if we want to find the optimal for not 2 units now, but 3 units, all right? Well, then we're going to get a different isoquant, and you're going to get a different optimal point. So instead of 2, what if we did 3? And instead of 3, what if we did 4? All right, and you get this collection of points. If you traced out the line made by that collection of points, you would get what is known as the expansion path. All right, you'd get what is known as the expansion path. It's the collection of optimal combinations as you change how much you want to produce. All right. So the set of optimal combinations given different production goals is the expansion path. All right. And this comes about by looking at the different optimal choices for the firm, given how much they want to produce. All right. And the slope, and generally the shape of the expansion path will give us some information about um, how capital or labor becomes more or less beneficial as we want to scale up production. All right. But don't worry about that too much right now. Um, on a party note, I want to bring back some things that we saw that we should have saw in Principles of Micro is that we can generalize the concept of these should say long run. Long run total cost, long run marginal cost, and long run average cost. All right. We can generalize these things to the long run. Oh, I have it here. Sorry. I try not to read off the slides too much, but I have them there for those of you that don't watch the videos, or those of you or like when you refer back to these things, you don't want to watch the video every time. All right. So we can also generalize these things to the long run. All right. And so what do we see? What do we see? We see that as quantity increases, of course, cost increases. And we see identical patterns to what we saw in the short run. All right. But now we're considering the long run. Um, Nonetheless, we still see identical patterns. We still see that up to a point, we have average cost is decreasing, decreasing, decreasing up to a point, and then starts to increase again. And we see a similar pattern for marginal cost as well. All right. And what do we remember from principles of micro? That this is what is referred to as returns to scale. All right. This is what is referred to as returns to scale. So when you have increasing returns to scale, that is when, as quantity goes up, as you go to the right, your average cost is coming down. All right. That so if increase your returns to scale, I should say not if, but when it's the segment of the long run average cost curve where long run average cost decreases as quantity increases. All right. And this is the part of econ where it's like, imagine you just started a business and you're fresh, right? You're a small business. So as you scale up, you will get better deals with suppliers. You will get better contracts with whoever you're buying your stuff with. You will be able to buy things at a lower price. All right. The price that I would pay right now to buy like blank t-shirts, if I had a t-shirt company, is going to be way, way higher than the price that like Target buys their blanks from their suppliers, right? Because Target is buying in mass amounts, so they're getting quite a bit of bulk discount. All right. And this is kind of the intuition behind returns to scale. That as your quantity goes up, that average cost of production comes down. Similarly, when long run average cost is unchanged, right? An overbar means fixed. We're not in statistics, so that doesn't mean average, it means fixed. When long run average cost does not change as quantity increases, then we just have constant returns to scale. Our costs do not go up, they do not go down, they just remain constant. And then finally, when we're too big and we shouldn't scale up anymore, we call this decreasing returns to scale. And that's where long run average cost is actually increasing as quantity increases. All right. So these are different. Remember, this is a long run. So these are different stages in the business life cycle. All right. And these are things that we should have talked about, or your principles of micro teachers should have talked about. But if they didn't, well, now you know. All right. If you don't know, now you know. All right. And then just one last thing that I think should be intuitive is that your long run cost, remember, in the long run, we can change capital and labor. But in the short run, we can only change labor. So a consequence of this that I don't want to spend time showing the mathematics, but I just want you guys to know this fact is that a consequence of this is that your short run cost will never be greater than your long run cost. All right. Your short run cost will either be equal or your short run cost will be greater than your long run cost. All right. And with all of that said, that wraps up what I want to say about the supply side. All right. So next, in the next two lectures, we will bring together supply and demand. We will see equilibrium. And there is where we're truly going to get the supply curve. But just as some intuition, remember we saw this like a cost minimization problem. So they produce an optimal quantity based on minimizing costs. Well, depending on how much the market power the firm has, that determines how much more from their costs can they charge for their price, all right? If it's perfect competitive, then they're making zero profit. But if they have if any, that's a little preview of what's ahead. But if they have any type of market power at all, you can charge a little bit of a markup. So we know it's just some intuition. If you want just like an intuitive way of how do we get the supply curve, first, they're going to figure out how do we minimize costs, and then they're going to charge their markup. And then that's how we're going to get the upward slope in supply curve. All right. But we will see this more in detail in the next two lectures when we talk about perfect competition. For now, we just needed to get these details of the supply side of things alone, straightened out. We need to get these things down pat before we can move to bringing them together. All right. So with that being said, that wraps up this lecture. I know it was a lot, so if you made it to this point in the video, I really appreciate you sticking with me. Um, any questions you have, please email them to me or send me a message on Canvas. Otherwise, I will see you guys next time. All right. Thank you.